Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! Hello dear students! Welcome to Precalculus Quarter 1 Module 1 Analytic Geometry. I am Mom Rose and I will be your teacher for this subject. The Precalculus course bridges basic mathematics and calculus. This course completes your foundational knowledge on algebra, geometry, and trigonometry. It provides you with conceptual understanding and computational skills that are prerequisites for basic calculus and future STEM courses. Before we begin, let me know what you already know by answering the pre-test. Now let's begin with Lesson 1. Lesson 1 is all about introduction of conic sections and the circle. Upon completion of this lesson, you should be able to illustrate the different types of conic sections, namely parabola, ellipse, circle, hyperbola, and degenerate cases. Determine the type of conic section defined by the second degree equation in x and y. Define a circle. Determine the standard form of equation of circle. Graph a circle in a rectangular coordinate system. Derive and illustrate the equation of the circle. Find the center and the radius of the circle of an equation, and convert the general equation of circle to standard form and vice versa. Completing the squares is very important in understanding conic sections, so let us recall this one first before we proceed. Here are the steps in completing the square method. Number 1. Rewrite the equation in the form x squared plus bx equals c. Number 2. Add to both sides the term needed to complete the square. Number 3. Factor the perfect square trinomial. And number 4. Solve the resulting equation by using the square root property. Let us consider a few examples. Let's start with number 1. X squared plus 8x plus 5 is equal to 0. The first step here is to rewrite the equation in the form x squared plus bx, so in this case it will be 8x is equal to c. Since our c is 5 and it is positive, then we'll transpose it, making it negative 5. The next step is to think of a constant that will complete the square. So let us write this one first. X squared plus 8x is equal to negative 5. The appropriate constant that will be added in this portion is based on the middle term, which is 8x. 8 divided by 2, whatever is the answer, square it. So 8 divided 2 is 4, squared, that would be positive 16. Remember that whatever you add on the left side will also be added on the right side to retain the equality symbol. Therefore, we can now factor the left side. The factor is quantity x plus 4. We got 4 by dividing 8 by 2. Quantity raised to 2 is equals to, perform the right side, so that will be positive 11. Now, square root is needed to get rid of the exponent 2. So the square root of x plus 4, which is raised to 2, is equals to the square root of 11. Again, always remember that whatever you do on the left side will also be done on the right side to retain the equality symbol. We will be left with x plus 4 since the exponent and the square root will be cancelled. The square root of 11 is equals to plus or minus itself. Since 11 is not a perfect square, we'll just copy this one, but do not forget that a square root will always have a plus or minus. Therefore, the value of x is equals to transpose this portion, so it will become negative 4 copy plus or minus square root of 11. So we will have two answers here, x sub 1 and x sub 2. In x sub 1, we'll have negative 4 plus square root of 11. That is approximately 0.68. While our other answer is negative 4 minus square root of 11, which is approximately negative 7.38. We'll now proceed to example 2. X squared plus 10x minus 4 is equals to 0. The first step is to rewrite the equation in the form x squared plus bx is equals to c. So this will be x squared plus 10x is equal to, since this is our c, we have to transpose this on the other side, making it positive 4. The next step is to find an appropriate constant that will complete the square. So again, let's write this one first. Now think of a constant that will complete the square. The same method, 10 divided by 2 is 5. 5 squared is equals to 25. So we'll write plus 25 on the left side and also do it on the right side, again to retain the equality symbol. We can now factor the left side. So our factor is quantity x plus 5. Again, 5 is taken from 10 divided by 2 squared is equals to, perform the right side, so that will be equal to 29. Again, place a square root on both sides to get rid of the exponent 2. Now, since the exponent and the square root will be cancelled, we will be left with x plus 5. And on the other side, plus or minus square root of 29, since 29 again is not a perfect square. Therefore, our x will be, transpose this one, so it will become negative 5, and simply copy plus or minus square root of 29. So our final answer will be x sub 1, which is, and x sub 2. So we'll start with x sub 1. We have negative 5 plus square root of 29, which is approximately 0.39, and x sub 2 is negative 5 minus, that is taken from plus or minus, so x sub 2 is minus, which is approximately negative 10.39. With this review, we can now proceed to the main topic, the conic sections. Let's start with the definitions. Conic section is a graph that results from the intersection of a plane and a double cone. A circle is formed when the plane is perpendicular to the axis of the cone. An ellipse is formed when the tilted plane intersects only one cone to form a bounded curve. A parabola is formed when the plane is parallel to a generator line of the cone, and an hyperbola is formed when the intersection of an unbounded curve and the plane is not parallel to a generator line of the cone and the plane intersects both halves of the cone. There are other ways for a plane and the cones to intersect, to form what are referred to as degenerate conics, a point, one line, and two lines. Let us now proceed to the next part, identifying a conic section. Since there are several conic sections, how do we identify one from one another? We will use the determinant b squared minus 4ac. If the answer to that one is less than 0 and a is equals to c, then it's a circle. However, if the answer of the determinant is 0, then it is a parabola. If the answer is less than 0, but this time a is not equal to c, then the answer is ellipse. If the determinant is greater than 0, then it is a hyperbola. The general form of the quadratic relation of the conic sections is ax squared plus bxy plus cy squared plus dx plus ey plus f is equals to 0. Let us now answer number 1. 2x squared plus 4xy plus 3y squared plus 12y minus 1 is equals to 0. We will first identify the values of a, b, and c. As you can see in number 1, in the general form, x squared is beside a, and in our given, 2 is beside x squared, so a is equal to 2. Next is b. b is beside xy, and in our given, xy is beside 4, therefore our b is 4. Lastly is our c. It should be beside y squared, and in our given, 3 is beside y squared, therefore our c is 3. Since we already have the values of a, b, and c, we can now proceed with getting the determinant b squared minus 4ac. We will simply substitute this one. Our b is 4, so we have here 4 squared minus, the 4 here is constant, multiplied to a, which is 2, and c, which is 3. So we have here 4 raised to 2 is equals to 16 minus 4 multiplied to 2 is 8, multiplied to 3 is 24. Doing the operation, our final answer is negative 8. Now we know that negative 8 is less than 0. Also, there are two options here, but take a look at the values of a and c. Since in number 1, our a and c are not equal, then let us write this one. A is not equal to c, therefore this is an equation of an ellipse. Let us now proceed to example number 2. 3x squared minus 2y squared plus 6x plus 10y minus 16 is equal to 0. Again, let's get the values of a, b, and c first. In the general form, x squared is beside a, and in our given, 3 is beside x squared, therefore our a will be 3. Next is, our b is beside xy, so we'll just have to find xy in our given, but sad to say it's not there, so our b is 0. Next is, c is beside y squared, so we'll have negative 2 here as our c. Now we are ready to get the determinant b squared minus 4ac. We will simply substitute here. our b is equals to 0, so that's 0 squared minus, again 4 is constant, times a is 3, times c is negative 2. So we have 0, negative 4 times 3 is negative 12, times negative 2, so that's positive 24. So our determinant is 24. Now 24 is greater than 0. Looking at the choices we have here, hyperbola. Therefore, number 2 is an equation of a hyperbola. Number 3 is 3x squared plus 3y squared plus 18x minus 16y plus 31 is equals to 0. Again, we will get the values of a, b, and c. The same method applies. Beside x squared is a, which is in the given, it's 3. Beside xy is b, wherein you cannot find it in the given, so simply place 0. Now c is beside y squared, which in the given is 3. We are now ready to solve for the determinant b squared minus 4ac. By plain substitution, our b is 0, so it will be 0 squared minus 4 is constant times a is 3 times c is 3. Therefore, our answer here is 0. 4 times 3 is 12 times 3 is 36. Therefore, our final answer is negative 36. As you can see, negative 36 is less than 0. So there are two options here. So look at the values of a and c. As you can see, in our given, a and c are equal. So we have here 3 and 3. A is equals to c, therefore this is an equation of a circle. Our last example is 4x squared plus 4xy minus 4x plus y squared minus 12y is equals to 0. Again, we will get the values of a, b, and c. In our general form, x squared is beside a, therefore our a here is equal to 4. Our b is beside xy. In our given, 4 is beside xy, so b is 4. C is beside y squared, and in here, we have this portion, there's no number, so automatically it's 1. So we are now ready to solve for the determinant b squared minus 4ac. Again, we'll simply substitute. Our b here is 4. 4 squared minus 4 is constant. A is 4 multiplied to c, which is 1. Therefore, we have here 4 raised to 2 is 16 minus 4 times 4 is equals to 16. Now 16 minus 16 is 0. Since 0 is equal to 0, according to our options, this is an equation of a parabola. That is all for today. Thank you and see you on our next video lesson. Hello everyone! We are now in the Introduction to Circles. Definition. Let C be a given point. The set of all points P having the same distance from C is called a circle. The point C is called the center of the circle and the common distance its radius. As you can see, we have a sample circle here with the center C and the point of a circle called P. Getting the radius of the circle will lead us to the standard equation of the circle using the distance formula. The distance formula is equals to the square root of quantity x sub 2 minus x sub 1 raised to 2 plus quantity y sub 2 minus y sub 1 raised to 2. Now all point, just like P, is an ordered pair x, y, and our center is obviously in 0, 0. Now let this be our second ordered pair, so it's x sub 2, y sub 2, and this one be our first ordered pair, so x sub 1, y sub 1. So to get the distance of line segment CP, we'll simply substitute the values here. So it's the square root of x sub 2 is x minus x sub 1 is 0, quantity is squared, plus y sub 2 is y minus y sub 1 is 0, quantity raised to 2. Now remember that line segment CP is our radius. So I will continue this portion here, so it will be x squared plus y squared. Now we want to get rid of the square root, so we will square both sides here, and we'll have r squared is equals to x squared plus y squared. We just got the standard equation of the circle. It's x squared plus y squared is equal to r squared. Again, the standard equation when the center is in the origin is x squared plus y squared is equals to r squared. Now what is the standard equation when the center is not in the origin? Just like our illustration here, the center is not in the origin. P is any point x, y, and the center here is, let's have any point like h, k. Now we will pattern the new equation to the previous one. So instead of x squared, we'll make it x minus h, and instead of y squared, we'll make it y minus k. And then we'll simply have the exponent 2 still equal to r squared. The corresponding x of our center is h, while the corresponding y of our center is k. Therefore, we will always pair x with h and y with k. That is all for today. Thank you and see you on our next video lesson. Hello everyone, we are now in the introduction to circles. Definition. Let C be a given point. The set of all points P having the same distance from C is called a circle. The point C is called the center of the circle and the common distance its radius. As you can see, we have a sample circle here with the center C and the point of a circle called P. Getting the radius of the circle will lead us to the standard equation of the circle using the distance formula. The distance formula is equals to the square root of quantity x sub 2 minus x sub 1 raised to 2 plus quantity y sub 2 minus y sub 1 raised to 2. Now all point, just like P, is an ordered pair x, y, and our center is obviously in 0, 0. Now let this be our second ordered pair. So it's x sub 2, y sub 2. And this one be our first ordered pair. So x sub 1, y sub 1. So to get the distance of line segment CP, we'll simply substitute the values here. So it's the square root of x sub 2 is x minus x sub 1 is 0, quantity squared, plus y sub 2 is y minus y sub 1 is 0, quantity raised to 2. Now remember that line segment CP is our radius. So I will continue this portion here. So it will be x squared plus y squared. Now we want to get rid of the square root. So we will square both sides here. And we'll have r squared is equals to x squared plus y squared. We just got the standard equation of the circle. It's x squared plus y squared is equal to r squared. Again, the standard equation when the center is in the origin is x squared plus y squared is equals to r squared. Now, what is the standard equation when the center is not in the origin? Just like our illustration here, the center is not in the origin. P is any point x, y, and the center here is, let's have any point like h, k. Now we will pattern the new equation to the previous one. So instead of x squared, we'll make it x minus h, and instead of y squared, we'll make it y minus k. And then we'll simply have the exponent 2 still equal to r squared. The corresponding x of our center is h, while the corresponding y of our center is k. Therefore, we will always pair x with h and y with k. That is all for today. Thank you and see you on our next video lesson. Welcome to getting the standard equation of a circle. Let's have problem 1. Center at the origin, radius 4. Since the center is at the origin, we will be using x squared plus y squared is equal to r squared. Our radius here is 4, so we will substitute that one in this portion. So x squared plus y squared is equals to 4 squared. Now let's rewrite that one, and 4 squared is equals to 16. This is our final answer. Let us now proceed to problem 2. The center here is negative 4, 3, and the radius is negative 7. Since the center is not in the origin, we'll be using x minus h quantity squared plus y minus k quantity squared is equal to r squared. This is our h and this is our k. We are now ready to substitute. X minus our h is negative 4, quantity squared plus y minus our k is 3 raised to 2 is equals to our radius is square root of 7 raised to 2. Remember that negative times negative is positive, so that will be x plus 4 quantity squared plus y minus 3 quantity squared is equals to the exponent and the square root will be cancelled, so what's left is 7. So this is our final answer. Let's now proceed to problem 3. We will consider the circle in figure 1.7. As you can see, the circle here, having the center 3, 1, is not in the origin. So we'll be using x minus h quantity squared plus y minus k quantity squared is equals to r squared. Now our h is 3, our k is 1. Now to get our radius, we have to consider a point here in the circle. We'll just get the distance from the center to that point. So we'll count 1, 2, 3, 4, 5. They are 5 units away, therefore our radius is 5. Since we already have the needed values, let us now substitute x minus our h is 3 quantity squared plus y minus our k is 1 quantity squared is equals to 5 squared. So let us rewrite that one. And 5 squared is equals to 25. And this will be our final answer. That is all for today. Thank you and see you on our next video lesson. Hello everyone, we are still on getting the standard equation of a circle. Let us start with problem 4. Circle A in figure 10 is this portion. So we'll focus on that on number 4. Since the center is -2, -1, which is not in the origin, we will be using x minus h quantity squared plus y minus k quantity squared is equals to r squared. Our h is -2 and our k is -1. Our r is still unknown, so I will be selecting a point here in the circle. I will be choosing this point. Now I will be counting the units from the center to that point. 1, 2, 3, 4. Since they are 4 units away, our radius is 4. Let us now substitute the values. X minus our h is -2 quantity squared plus y minus our k is -1 quantity squared is equals to our r is 4 squared. Again, negative times negative is positive, so this will be x plus 2 quantity squared y plus 1 quantity squared is equals to 16, and this is our final answer. Let us now proceed to problem 5. This time we will be considering circle B. As you can see, the center is in 3, 2. Since it is not in the origin, we will be using x minus h quantity squared plus y minus k quantity squared is equals to r squared. Again, our h is 3, our k is 2, and our r is still unknown. I will be selecting a point here in this circle, and I have chosen this point. Now I will just count the number of units from the center to that point. 1, 2, and 3. Therefore, our radius is 3. We are now ready to substitute. X minus our h is 3 quantity squared plus y minus our k is 2 quantity squared is equals to 3 squared. Now we'll just rewrite this one. X minus 3 quantity squared plus y minus 2 quantity squared is equals to, that's 9. So this is our final answer. That is all for today. Thank you and see you on our next video lesson. Hello everyone! Today we will discuss getting the standard equation of a circle. We are done answering problems 1 to 5, so we'll have problem 6. We have here center 5, negative 6, tangent to y-axis. Let us plot that one first. 5, negative 6. Since that is not in the origin, we'll be using x minus h quantity squared plus y minus k quantity squared is equals to r squared. Our h is 5 and our k is negative 6. Now our r is still unknown. Since we have the center here, therefore our circle is in this portion. When you say tangent to the x-axis, our circle here touches the y-axis in one point. So, here, I will be considering this point. So, we'll just count the number of units from the center to that point of the circle. We have 1, 2, 3, 4, and 5. Therefore, our radius here is 5. We can now substitute the values. X minus our h is 5 quantity squared plus y minus our k is negative 6 quantity squared is equals to 5 squared. Remember that negative times negative is positive, and 5 squared is equals to 25, so this is our final answer. Problem 7. Considering the same center, but this time it's tangent to x-axis. Again, we'll plot the center 5, negative 6. Since it's not in the origin, we'll be using x minus h quantity squared, y minus k quantity squared is equals to r squared. Our h is 5, our k is negative 6. Our r is still unknown. Our circle is in this portion, and since it's tangent to x-axis, the circle should touch the x-axis in one point. So in this portion, I will be considering this point here. Now I will count the number of units from the center going to that point. So we'll have 1, 2, 3, 4, 5, and then 6. Therefore, our radius here is 6. We're now ready to substitute. X minus 5 quantity squared plus y minus negative 6 quantity squared is equals to 6 squared. We'll rewrite this one. Again, negative times negative is positive. And 6 squared is equals to 36. And this is our final answer. That is all for today. Thank you and see you on our next video lesson. We are still on getting the standard equation of a circle. We are now on problem 8. It has a diameter with endpoints A, negative 1, 4, it's in this point, and B, 4, 2, it's in this point. So these are the two endpoints of our circle, and in the middle portion here, we will be getting our center. So since our center is not in the origin, we'll still be using x minus h quantity squared plus y minus k quantity squared equals r squared. The values of our h and k are unknown, but we can get these values if we will consider the middle portion of our diameter. So let's start with the x. Negative 1 plus 4 divided by 2. It's the average. So let's have now the y. 4 plus 2 divided by 2 is equal to, that is 3 divided by 2, and then 6 divided by 2, which is equal to 3. Plotting our center, we have here 1.5 and 3, so our center is located here. Again, that's 3 halves, 3. Now we will be using our center and our point here to get the radius. We will be using the distance formula to get the radius. Again, let me recall, that's x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 quantity squared. Substituting the values, we have here negative 1 minus 3 over 2 quantity squared plus 4 minus 3 quantity squared. That is equivalent to the square root of 29 over 4. Since we have now our h, our k, and our r, we can now substitute this one here. So our standard equation is x minus 3 over 2 quantity squared plus y minus 3 quantity squared is equals to the square root of 29 over 4 raised to 2. So we have here, rewriting this one, since the square root and the exponent will be cancelled, we have 29 over 4. That is all for today. Thank you and see you on our next video lesson. We are now on rewriting standard equation to general equation. The standard form of the circle, as you already know, is this form. Now we'll try to make it into general form this time. So let's have our first example. As you can see, our example here is in standard form. X plus 4 quantity 2 is just the same as x plus 4 multiplied to itself. Do the same on the other side. Y minus 3 multiplied to itself is equal to 7. Doing the FOIL method, we have here x times x, x squared, plus 4x plus 4x plus 16, plus we have here y squared minus 3y minus 3y plus 9 is equal to 7. Now combining like terms, we have x squared plus 8x plus 16 plus y squared minus 6y plus 9 is equal to 7. Now let us rewrite this one. X squared plus 8x. Now 16 and 9 can still be performed. So we'll write the answer later. Y squared minus 6y plus 25 equals 7. Our answer should be in this form. So we have x squared plus y squared plus 8x minus 6y. We'll just copy 25 here. We have here on the right side 0, so we'll transpose from positive 7, it will become negative 7, and still they can be simplified. So x squared plus y squared plus 8 x minus 6y plus 18 is equal to 0. This is our final answer. For a bonus tip, I'll be showing a shortcut in easily multiplying a binomial to itself. Let's have here x plus 4 quantity squared. So we'll just square the x, so that would be x squared. And we'll multiply 4 times 2. We have 8. And then just add x. And then 4 squared, we have 16. Let's have problem 2. We have here a new given. Remembering the bonus tip, we have x raised to 2 is x squared. Negative 3 times 2 is negative 6, just add x. Negative 3 squared is positive 9. Y raised to 2 is y squared. Negative 2 times 2 is negative 4, just add y. And then negative 2 squared is equals to 4 equals 9. Now let us perform or operate the constants. So we'll copy this one first. And then 9 plus 4 is equals to positive 13 is equals to 9. Now we will arrange this one according to the general form. So we have x squared plus y squared minus 6x minus 4y plus 13. Again, the right side should be 0, so we'll transpose, making it negative 9. Now we can still operate the constants, so we'll copy this one first. And then the answer is 4 equals 0. This is our final answer. That is all for today. Thank you and see you on our next video lesson. Hello everyone, welcome to rewriting general equation to standard equation. From general form, we will make it into standard form so that we will get the center of the circle and its radius. Then we can graph. So we have here example 1. The first step is to regroup the terms with the same variable. So we have here the variable x squared minus 6x. And then there's only one term with variable y squared, and then just copy 7. Since our group here has a middle term, we can now complete the square by thinking of an appropriate constant to be placed here. So allow me to just rewrite this one. Now the appropriate constant to be placed here should depend on your middle term. So negative 6 divided by 2, that's negative 3. Squared it, so that will give us positive 9. Now also place positive 9 on the right side, since whatever you do on the left side should also be done on the right side to retain the equality symbol. Now we can factor this out. X minus 3 quantity squared, again negative 3 is from negative 6 divided 2, plus just copy y squared and then perform this, it's 16. Now looking at the form, we still have to transform this one into r squared. So rewrite this portion equals 4 squared because it's equal to 16. Therefore, our center here is, or h is 3, and we don't have our k here, so we'll just place 0, and our radius is 4. We are now ready to graph since we already have the needed values, we already have the center, and we already have the radius. Now let us plot the center here. That's 3, 0. And since the radius is 4, we have to count 4 units from all sides. 1, 2, 3, 4, that's 7, 0. Then 1, 2, 3, 4, that's 3, negative 4. And then 1, 2, 3, 4, that's negative 1, 0. And 1, 2, 3, 4, that's 3, positive 4. Now these 4 dots here are all points of the circle, so we'll just use those dots to create our circle. Here's our circle. Let's now proceed to problem 2. Again, our first step is to regroup all of the terms with the same variable. We have x squared minus 14x, and then we also have here y squared plus 2y, and then copy negative 14. Now we have to complete the square of this group, so allow me to just rewrite, and then also to this group. Now the appropriate constant here depends on the middle term, negative 14. So negative 14 divided by 2, that's negative 7. Square that 1, that will give us positive 49. Again, whatever you place in the left side should also be written on the right side. Now let us proceed here. The number here will depend on the middle term. 2 divided by 2 is 1. 1 squared is 1. Also write that one on the right side to retain the equality symbol. We can now factor this one. We have x minus 7 quantity squared. Again, negative 7 is from negative 14 divided by 2. Then y plus 1 quantity squared. Again, that is taken from 2 divided by 2. And on this side, we have to perform or operate this. It will give us positive 36. Now looking at our standard form, we still have to make our right side into r squared. So let us rewrite this portion. And then this is 6 squared, because 6 squared is equals to 36. We now have the value of our center, and that is our h is 7, and our k is, since that is negative and this is positive, so it's negative 1. Again, because negative times negative is positive, and our radius is 6. Let us now plot the points. Our center here is 7, negative 1. And our radius is 6, so we'll count 6 units. 1, 2, 3, 4, 5, and 6. So it's 13, negative 1. And 1, 2, 3, 4, 5, 6. So that's 7, positive 5. And then 1, 2, 3, 4, 5, 6. So that's 1, negative 1. And 1, 2, 3, 4, 5, 6. That is 7, negative 7. Now all points here are all points of the circle, so we'll use it. And here's our circle. We'll now proceed to problem 3. The same first step here, we have to group the terms with the same variable. So we have here 16x squared plus 96x, and then other group is 16y squared minus 40y, and then copy 315. Now as you can see in our groupings, 16 is common, so we have to factor it out. 16, what's left is x squared. 96 divided 16 is 6x. And then still factor out 16 here. So y squared Negative 40 divided 16, it will give us 5 over 2y. And then copy 315. The next step is to complete the square here. So allow me to just rewrite. And we'll leave that portion to the appropriate constant. The constant here is 6 divided by 2 is 3, 3 squared is 9. Also write on the other side. But remember, there's 16 outside, so we have to add 16 times 9. Now in here, input in your calculator negative 5 halves divided by 2 squared at 1. It will give us 25 over 16. Again, there's a presence of 16 outside, so we'll do it also on the right side. We can have factor here. X plus 3, again that's 6 divided by 2, quantity squared. Plus on this side we have y. 5 halves divided by 2 is 5 over 4, quantity squared. And we have to perform or operate the right side. It will give us 484. Now since 16 is common, we have to divide both sides by 16. So let's have over 16 on the other side as well, over 16. So we are left with x plus 3 quantity squared, and then plus y minus 5 over 4 quantity squared, and this is 121 over 4. Now we have to make it in r squared form, so just copy and then this is 11 over 2 raised to 2. From this, we'll get our center, so that is positive, so our h is negative 3 and our k is 5 over 4 and our radius is 11 over 2. So to make it simple to plot, let's have the decimal form here. So this is negative 3 and that is 5 divided by 4 is 1.25, and then 11 over 2 is equal to 5.5. Let us now plot the center. So it's negative 3, positive 1.25, so it's in this portion, and this point is our center, and we'll have to count 5.5 units. 1, 2, 3, 4, 5.5. So this is 2.5 and then 1.25. Then another 5.5. 1, 2, 3, 4, 5.5. So this is 4.25. So that point is negative 3, negative 4.25. And 1, 2, 3, 4, 5.5. So that's negative 8.5, 1.25. And last one, we have 1, 2, 3, 4, 5. So that is negative 3, 6.75. So we will have to make use of those dots to create our circle. assuming that this is a perfect circle, so this is our graph. That is all for today. Thank you and see you on our next video lesson.